All right, so in the last video, we saw that parallel lines have same slopes but different y-intercepts. Let's do this. Y equals 4 halves x plus 10, and y equals, let's say, 6/3 x plus 20 over 2. Okay, now, here are two equations, and we're going to have to figure out, without a picture, without a graph, if these are independent, dependent, consistent, inconsistent. Okay, so let's look at what's going on here. I tried to fool you by making these look as different as possible, but lo and behold, if you actually simplify both of these linear equations, they come out to be the exact same thing. Do you see that 4 over 2 is just a fancy way of saying 2? 4 divided by 2 is just 2. Also, 6 divided by 3 is just reduced to 2. All right, how about over here? We've got a 10 over here. How about 20 divided by 2? Well, 20 divided by 2 is just 10 itself anyway. So, lo and behold, while I tried to disguise these two equations, it turns out they are the same equations. So therefore, if I were to draw them, they would be on top of each other. Two lines that have the same slopes and same y-intercepts are dependent, because they're the same line. They're not different lines. Dependent. And since a line is on top of the other line, they're going to share an infinite number of solutions. And an infinite number of solutions certainly is at least one solution in common. It's an infinite, but we only needed one solution in common for us to call it consistent. So here we have a consistent scenario.